Hello. Today we're going to be doing function operations, and a lot of this will be kind of review and some new ways to look at some things you already kind of know what's going on with. So we're going to start with a little warm up, which is regular operations. What are the four basic operations? You guys should know this. This is addition, subtraction, multiplication, and division. Okay, so we're going to evaluate the following expressions, meaning we're going to use order of operations. And we're going to start with our multiplication here, and this becomes 6 plus 12, which is 18. Okay, grouping symbols first. So this will give us 9. This will give us 4 minus 5 is negative 1. So the 9 divided by negative 1 is negative 9. Order of operations says we'll do these exponents first. 2 to the third is 8. So now I have 6 plus 8 times 3. 8 times 3 is 24. Do that next. 6 plus 24 gives us 30. So just a little refresher on the order of operations for you. Okay, which operations are defined for any two real numbers? So any two real numbers, which operations are defined? Can you add any two real numbers? Yes. Can you subtract them? Yes. Can you multiply? Yes. Can you divide any two real numbers? And that is the tricky one. No, because you cannot divide by 0. So since you cannot divide by 0, those are the three that are only defined for all of them. Which operations are commutative, which means order doesn't matter. So 2 plus 3, is that the same thing as 3 plus 2? Addition is commutative. Is subtraction commutative? No, because 2 minus 3 is not the same thing as 3 minus 2. So addition is commutative. Multiplication, 2 times 3 and 3 times 2. Multiplication is commutative. And division, 2 over 3 is not the same as 3 over 2. So commutative, the back and forth, the only ones that work are addition and multiplication. Associative means doesn't matter if you group the symbols, 2 plus 3 plus 4. Doesn't matter if I put the grouping symbols here or here. It does not matter with addition. It does matter with subtraction. Multiplication, it does not matter. So those are the two once again. At the end of this lesson, we're going to use our operations on functions, and you're going to find some values of functions when you add, subtract, multiply, or divide them. It's just a nice little, cute little chart I found for you. This is going to be the practice now. Okay, we're going to add functions, and you're just going to find a rule to add them. So the big thing here is this new notation. This is said f plus g of negative 1. So what this is telling you is it's going to add the functions, and we're going to plug negative 1 in. So this is the exact same thing as f of negative 1 plus g of negative 1. So you're going to take f of each value and then add them together. Well, f of negative 1 in, these are separate examples, by the way. Oh, maybe they're not. No, they're the same. Sorry, false alarm. F of negative 1, if I plug it into the equation, f of negative 1 would be negative 1 squared, which is just 1. G of negative 1 would be negative 1 minus 6, which is negative 7. 1 plus negative 7 is negative 6. You could also look at your table. F of negative 1 is 1. G of negative 1 is negative 7. 1 plus negative 7 is negative 6. Now, there's another way you could have done this problem. You could have taken f plus g of x and then plugged in negative 1. So you could have taken f of x plus g of x and then plugged in negative 1. So what does this look like? Well, f of x is x squared. G of x is x minus 6. There's no like terms here, so f plus g of x, a rule for this would just be x squared plus x minus 6. If you plug negative 1 into that guy, notice the parentheses are kind of important. 1 minus 6 is 1 minus 1 is 0. 0 minus 6 is negative 6, which we got the other way as well. Okay, so I think it's easier to take f of negative 1 plus g of negative 1. But if you wanted to make a rule and then plug in negative 1, you could also do that. Let's see. How about subtraction? Would subtraction be the same way? Well, subtraction will be a little bit different. Let's go back to our example with the -1. Let's do f minus g of -1 using the table. F, minus g of -1. So that would be f of -1 minus g of -1. Well, f of -1 was 1 minus g of -1 was -7. 1 minus -7 becomes 8. What if you were going to make a rule? Well, the rule for subtraction is one step trickier than addition because you would have to take f of x minus g of x. And when you subtract g of x, you're going to have to subtract all the pieces, which means you're going to have to distribute that sign and x squared minus x plus 6. So if you plug the -1 in this point, oh, not plus, we're doing a minus. F minus g of -1, if you plug it in here, you get -1 squared minus -1 plus 6. 1 plus 1 plus 6, that's that 8 we were looking for. All right, so let's do some practice here. Here are some tables, and they want us to do p minus q of 2. So that's the same thing as p of 2 minus q of 2. P of 2 would be 3 minus q of 2 would be -2. 3 minus -2 becomes 5. Let's try these next guys. They want a rule this time. So we're going to take s minus r. We're going to be careful with subtraction because order matters and we have to subtract all the pieces. This is the same thing as s of x minus r of x. So s of x is 2x plus 1 minus, in parentheses, r of x is -x squared plus 3x. Subtract all the pieces or distribute. So it becomes a plus x squared and now a minus 3x. Combine like terms, x squared minus x plus 1. That is the rule. What if you do r minus s of x? Are you going to get the same answer? Well, we shouldn't because it's not commutative, but let's see what happens. R of x minus s of x, because that is what this means. R of x is -x squared plus 3x minus, in parentheses, the 2x plus 1, because we need to remember to subtract all the pieces, -x squared plus 3x minus 2x minus 1, -x squared plus x minus 1, and they are definitely different. So that's some practice with subtraction. What other things can we do? We're going to look at these graphs. And I don't really like the way this graph looks. So I'm going to kind of talk to you about another example that I found real quick first. I opened it up. If I can find it here. There it is. So what we're going to do is we're going to take this f of x line and we're going to add it to the g of x line. Now, there's two ways you can think of it. The first way would be, well, what's the equation of f of x? Well, this equation for f of x equals, if you can see, the y-intercept is 2, and the slope, or rising 1, running 1, so that's just x plus 2. Then the g of x, that guy, has a y-intercept of -4, and the slope is rising 2, running 1, so this is 2x minus 4. If you take f of x plus g of x, you would have x plus 2 plus 2x minus 4, which is 3x minus 2. That will be the graph of the sum. And I could graph that if I wanted to, right on here. But first, I'm going to show you another way you can think of it. If you think about this line here, and you take the two values that are on the graph. So I have here a 2 and a -4, and I add them up. 2 plus -4 gives me -2. So on my new graph, -2 is going to be on my new line. Now, if you go to the second line here, what do I have? I have a 3 and I have a -2. So I'm going to take 3 plus -2, which is 1. And on my new line, I'm going to have a 1. Let's go to this guy. Okay, I have a 0 and a 4. A 0 and a 4 gives me 4, and that's enough for me to see what my line would be, and I continue going, but you can see that the slope here is 3. If I do the next point, it would be right here, and you could connect it. Well, guess what that blue line is the equation of? 3x minus 2. So you can see it by adding the points or by adding the lines. Now, how about subtraction? The lines are the same. So when I do f of x minus g of x with subtraction, I would have x plus 2 minus, in parentheses, 2x minus 4, distribute x plus 2 minus 2x plus 4, which will be negative x plus 6. So that's what I expect the graph to look like. Now, order does matter when you're going to do this one, so be very careful that you take the f value first minus the g value. And what do I have on the f? I have a 2. Oh, that's going to be hard for you to see. A 2 minus a negative 4 becomes 6. So on my new graph, 6 will be the y-intercept. Go down the second line here, and I got a negative 2 and a 3. I will have a 3 minus a negative 2, which becomes 5. So on that next yellow line, I'm going to be at 5. I wanted that to be blue. On my next yellow line, I will have a 4 minus 0, which is 4. And you would continue that, and there is the line. So you can see how you can look at it graphically as well. I didn't quite like the example they gave, if I can find it even. Where are you guys at? So many flip charts open. Here it is. What they did was they took g of x times f of x. So they took x squared times x minus 6. It looks like. No, they added them. X squared plus x minus 6, and they got x squared plus x minus 6. So if you looked at those lines, look, I have a 0 and a negative 6, and my new point was a negative 6. I have a 1 and a negative 4. Oh, not a negative 4 at all. A 1 and a negative 5. 1 plus negative 5 is negative 4. That's where that guy came from. Let's use him. A 1 plus negative 7. And here's the new guy right there. And let's see if I can find another nice point here. How about this? 4 and negative 8 would be negative 4. So there's some of the points from that graph. So that's how they did it by graphing, or you could just add them up and then graph the result. More practice. What if you take f of x plus f of x plus f of x? Well, that would be x squared plus x squared plus x squared, which would be 3x squared. That is the exact same thing as 3 times f of x. It's called scalar multiplication. You're taking 3 times x squared, and you also get x squared. What if I wanted 3 times f of 2? Well, find f of 2, go to function f, take out the x and plug in a 2. That would be 2 squared, which is 4. 3 times 4 would be 12. Next, it says, if the opposite of g of x is negative g of x, then what would negative g of x be here? Well, negative g of x would be the opposite of the entire function x minus 6. So you would have to distribute. That would be negative x plus 6. And what happens if you take g of x plus negative g of x? Well, if you take x minus 6 plus negative x plus 6, they will undo each other, and you will get 0. Domain and range when you add them. Domain and range is talking about what numbers you can plug into your function machine so that they won't get broken. And you can assume you can plug anything you want into a machine. Usually the machine is negative infinity to positive infinity. For example, this x squared machine, I can plug whatever I want into this. I can plug in 0 and it shoots out 0. I can plug in 1 and it shoots out 1. I can plug in -3 and it shoots out 9. Nothing will break this machine. So usually the domain is all real numbers. However, there are some risks that will break machines. The only machines that can be broken for you right now would be anything dividing by 0. For example, if I have 1 over x, I can plug anything I want into this machine with the exception of 0. Because if I plug in 4, I get 1/4. If I plug in -7, I get -1/7. But as soon as I plug in 0, I'm dividing by 0, and that breaks the machine. So the domain of this machine would be x cannot equal 0, but x can be anything else. Um, and the other risk factor is square roots of a negative. If I have a square root of x machine, I can plug all positive numbers into this machine. I can also plug in 0 because the square root of 0 is 0. The square root of 2 is just the square root of 2, which is weird, but it's okay. If you can take the square root of 4 and you would get 2. But when you plug in negative values, it breaks the machine. So we would say that all these numbers x has to be greater than or equal to 0. To find the range values, you will actually need to check out the graphs and look at the picture. The graph of y equals x squared looks like this, and it goes left to right forever, but it bottoms out here at 0. So the range is y is greater than 0, or you could also write it as 0 to infinity. If you graph the square root of x, its graph looks like this, and your graphing calculator can help you. The domain is x is greater than equal to 0, like we just said, or 0 to infinity. And the range also bottoms out at 0. So that is also 0 to infinity. Domain and range is tricky, but we're going to get lots of practice with that this year. So let's practice. What is the domain and range of g and k? Well, g of x is just a line. There are no risk factors for g of x. So for the domain of g of x, the domain we say is either all real numbers, or you can say negative infinity to positive infinity. As far as the square root of x, for k of x, we have risk factors. The domain, we know that x can't be negative, so it has to be greater than equal to 0. So you can either write it like this, 0 to infinity with a square bracket, or you can say x is greater than equal to 0. You could also say the set of all x such that x is greater than equal to 0. I won't be picky on that. The range we also just talked about would be 0 to infinity or y greater than equal to 0. Now, what about their sum? What if I add them? I'll get the square root of x plus x minus 6. Now, I don't know what that graph looks like off the top of my head, so I would graph it. I would take a look in my graphing calculator and see what I'm dealing with. And I should have had this open already, so I apologize. Okay. Y equals the square root of x. Now, when you get the square root of x, you're going to take the right arrow out of there, plus x minus 6. So let's look at the domain and range of this guy. Let's look at the graph. Oh, my zoom's a little messed up, so I'm going to hit zoom 6 to see if I can see it clearly. Okay, and it looks kind of weird. Now, if you can't quite tell what's going on, you can look at your table. You can change the zoom a little bit, but it looks like I can't have negative values, and that makes sense because I would get negative under a square root, which is not okay. So the domain is going to be x is greater, what am I doing? X is greater than equal to 0 or 0 to infinity. Now, for the range is the down up. For the range, it looks like I'm bottoming out here at 1, 2, 3, 4, 5, 6, negative 6. And I do think it can be negative 6 because I can have 0 here. So this is going to be a solid dot, and it will be negative 6 to infinity up forever. So you're just going to look at your graph and see if you can get an idea of what's going on based on that picture. Okay, think about the commutative property of real number operations as it applies to addition and subtraction. How do you think this property might extend to multiplication and division of functions? Okay, well, I think commutative would be just like it was with addition subtraction. I do think multiplication would be commutative, but division is not, just like subtraction is not. And we talked about that a little bit earlier. So what about multiplying functions? This is really important. You can write f of g like this, or you can put a solid dot there. And the rules are just going to be the same. F of -1 times g of -1 and multiply the answers together. F of -1 would be -1 squared, which is 1, times g of -1 would be -1 minus 6. So 1 times -7, and I'm going to get -7. Your other option could be to actually find the rule. You can take x squared times x minus 6. You will have to distribute. That is x cubed minus 6x squared. Now you can plug the -1 in. -1 to the third minus 6 times -1 squared. Lots of negatives here. -1. This will be a minus 6 times a +1, which is also -7. So you can multiply functions as well. But division is going to always cause problems because when you divide, look what happens. If I take the x squared over x minus 6, I went from two things that do not have a risk to an equation that does have a risk of being broken when I talk about the domain. So you do have to be a little bit careful here. Anytime you divide, you have to look at whatever would be on bottom. You say, hey, hold the door. That guy cannot equal 0. So when you're done, after you write the x squared over x minus 6, and that cannot be simplified any further, you would also have to say x cannot equal, well, what would make this 0? What would break the machine, guys? If I add 6 to both sides, if x equals 6, my machine would be broken. So you also have to say x cannot equal 6. So this would be the rule, and you have to put this with it, otherwise the rule is not valid. Let's do some practice here. We're going to multiply m of x times n of x. So I'm going to take x times x squared plus 4x. I'm going to have to double distribute. That will be x cubed plus 4x squared. Let's evaluate that when x equals -3. Well, since I already have the rule here, I can take -3 to the third plus 4 times -3 squared. That will be -27 plus 4 times 9. -27 plus 36, and I'm getting +9. You also could have taken -3 into this guy. -3 squared plus 4 times -3, which would have been 9 plus -12, which is -3, times -3 again for this guy, which would be +9. How about when you divide m over n of x? So I'm going to have x squared plus 4x over x. That will clean up a little bit for me. The first thing I have to say is what x cannot equal. What would break the machine? X cannot equal 0. Now this guy can simplify further because all three pieces have an x in common. So this would simplify to x plus 4. You can only simplify if they all have something in common, and they do here. What if we had -3 in this case? Well, it would be -3 plus 4, which is 1. So what does this mean? I do want to talk about this for 1 second. What this means is if I graph x squared plus 4x over x in my graphing calculator, let's see, y equals x squared plus 4x divided by x, I should get a picture of a line. I'm going to hit zoom 6 because my zoom might be messed up. Oh, I need parentheses. X squared plus 4x. Oh, what am I doing? Divided by x. I should get a line. What is happening? Divided by x. There we go. But we said x cannot equal 0. Well, it looks like it equals there, but look what happens when you look at the table. If you go to the table, look what it says at 0. Do you see how it says error? Because it knows that would break the machine. So I think it's interesting. That's called a hole in a graph, and we'll talk more about that later. But that's what is happening whenever you have domain restrictions. Okay, and we're getting close to being done. This is a long section, guys. How about this? G of h of x, g times h of x, excuse me, when you have two big guys, okay? So you're going to take x minus 6 times 6x cubed minus x squared. This time you're going to have to double distribute. Some of you call that FOIL. We will have to do that and combine like terms. So let's see what we got here. This will be 6x to the 4th minus x to the 3rd minus 36x to the 3rd plus 6x squared, which gives you 6x to the 4th minus 37x to the 3rd plus 6x squared. So when you multiply those guys, you get something pretty big there. That was from pretty complicated math. And on this one, what would the quotient be of h and f? H divided by f would be 6x cubed minus x squared over x squared. Keep in mind, first you have to tell me what x cannot equal. It cannot equal 0. Now you can simplify, because that would give me 6x, and this would give me minus 1. And it would be 6x minus 1, but x cannot equal 0. Last thing is looking at a way you could use a spreadsheet to talk about functions. This is the revenue and profit and cost functions. So if the revenue function is $20 per item, that's how much money you're making, but it costs you $5 per item to make, what would the profit be? Well, you would just take R of X minus the C of X, and the profit will be $15 per item. And you can kind of see what they're doing here with their spreadsheet. They're doing it per item. 20, this is the number of items. So 20 times 1 is 20, and then they subtract to get the profit. 20 times 5 is 100, 5 times 5 is 25. They subtract to get the profit. I actually did a lot of work with spreadsheets this summer. I kind of like them a little bit more. Okay, so this one, video games sold is X, the revenue is this, the cost is this. What would the profit be? It'll be R of X minus C of X. You will subtract them. So it'll be 60x minus, in parentheses, 12 plus 7x, distribute. So that will be what? 53x minus 12. What would the profit be from selling 20 video games? You can take 53 times 20 minus 12, and you'll get $1,048. Okay, so that was a lot today. We will have some time for questions, but the math wasn't too hard. It was just a lot at once. Okay, thank you.